what I'd like to talk today about is making materials mobile friendly. That can be a lot of different things. So the mobile internet, internationally, the mobile internet is more than half the internet. Internationally, more than half of all internet access takes place on a device like this or this, as opposed to a computer. In the US, we're a little behind international setups. I don't think I'll use that bit. If that's going to cause trouble, I'll just yank it. But we're getting close. The projections are that 2012, 2013, or 2013, 2014 rather. Have to get used to it. It is 2012 now. 1 year from now is 2013. Mobile internet use will be more than half of internet use in the US as well. This came out September 30th last year. What kind of computer would you get? Something less irrelevant, a tablet, a smartphone, anything but another clunky old desktop. So we've just gotten comfortable with an obsolete technology. But if you're going to set things up to work on the mobile internet, that's a little tricky. So people accessing things online on the mobile market, Android has a 39% market share. iOS, 28% market share. BlackBerry still hanging on at 20%. It's been falling. Windows Mobile and Windows Phone 7 is up to 9%. Palm and Symbian are dying. What's more, Android, while the largest one, Android is something that each individual manufacturer can tweak and does their own way. So you have lots of little variations within Android. So if you are going to set things up to work, you have a lot of different operating systems to deal with. As such, for a typical instructor, it doesn't make a lot of sense to say, I'm going to build a separate app for my class to use. I'm going to build something that I have to then set in Apple, set for Android, maybe set for Windows. Relatively few students are represented in the BlackBerry share. It makes a lot more sense to say, how can I set something that will work generally? How do I find something that is friendly to mobile platforms and works in general for lots of different things? And if you are old, as I am, you remember the 90s when you had to say, oh, I'm writing this, and how does this browser handle this thing? How does that browser handle that thing? How do I then write something that works in all the different browsers? We're headed right back to that era again. And hopefully we will cycle through where people start to get them all together and back and forth and back and forth. So some general ideas on designing mobile-friendly things. And then I'll talk about some of the specific tricks you can use if you want to get into some of the more mobile type things. If you're setting things up to be mobile friendly, I have too many mics up here. In your style sheets, use fluid layouts. In general, you are better off to let the device make as many decisions as it can. Don't you try to tell it, I want this to be in 14-point type, and I want that to be an 18-point type, because you don't have any idea what size device they're looking at and what the appropriate size for that is. Let the device make those decisions. Using fluid layouts in CSS is usually a better thing. If you are trying to tap links, be careful that they're far enough apart. If you have a screen this size, at least my finger tends to get a fairly decent percentage of the screen there, and you want to be sure that there's enough space between the links that they can actually type on them and hit the link they want and not the one next to it. PDFs tend to work fine, but Java and Flash don't, and should probably be avoided. Those are just basic things you can do and probably should do with any website you're setting up now. You can expect your students to start looking at it online and start looking at it on a mobile device. If you want to get fancy, there are things you can do that can detect what browser's coming in and can say, oh, this is a mobile browser, I'll use my mobile style sheet. Oh, this is a desktop browser, I'll use my desktop style sheet. I personally, I'm busy teaching. I don't have time to get lots of those sorts of things done. Now, there are some things you can do to make fancy things. HTML5, many of the things that we've used plugins for in the past are now moving into HTML5. The source I found most helpful to this is Dive into HTML5 by Pilgrim, which if you type Dive into HTML5 into Google, it will take you to the book, and you can read the whole book online for free. You may also, if you prefer, to have an actual hard copy of it, order it from O'Reilly or from Amazon, except they changed the name. It's HTML5 Up and Running. So HTML5 gives you a variety of different things. You can do quite a lot with this. For instance, if you've seen America's Finest News Source, The Onion, this is the iPad app for The Onion. This is HTML5. This is building something in HTML5 and then wrapping it to make an iPad app. But internally, this is an HTML5 creation. So you can use HTML5 in your web pages, but if you want to turn them into an app, it is possible to take them and wrap them and package them as apps as well. And you can do that then to say, I'll set my HTML5 page, I'll get it working, and then I'll wrap it. I'll have to tweak the wrapper for an iPad versus how I tweak it to go on a smartphone, you know, how I'd get it to go on an Android phone. But there are wrapper packages that will do that for you. And I mean, this is something that, you know, actual sites making actual money actually do, not just the short thing.
Is HTML5 friendly for all devices?
Almost. So is HTML5 friendly for all devices? The problem is, like back in the day, HTML5 has slightly different implementations for all devices. Most things other than video work fairly smoothly across multiple devices. Video depends upon the codec, and that will be different for different devices. And there is code available out there that you can detect the device and say, oh, I need to use this codec for this device and this codec for that device. But if you want to get videos up there, you can do that. But then you have to prepare your videos in a couple of different formats and have your setup recognize who's coming at me, what format are they likely to be able to handle. So, but this basically gives you tools for building a bunch of the things that you would do with Flash, frankly, a number of the things you would do with Java and things. If you want to get fancier, then some more programming would be JavaScript. One thing I should probably have noted about HTML5, HTML5 works pretty well with every browser except Internet Explorer prior to 9. Internet Explorer 9 implements HTML5 fairly well. But anything older than that, and Internet Explorer 7 and 8 still have a substantial market share. Now, they have a much smaller market share on campus than they do nationally. Students tend to have learned that they prefer other browsers and things. If you want to get into doing something that involves some actual coding, JavaScript is the right tool. And this is very surprising. I remember when JavaScript was just a baby and you could use it to do little baby things, and you couldn't do anything other than little baby things in JavaScript. But the language is all grown up now. And you can actually do a great deal with it. If you do, I strongly recommend getting used to some libraries. Probably the best general purpose library I found is jQuery. So this lets you simplify a lot of your coding. Two things that I use specifically, because I'm a mathematician, MathJax lets you write formulas. So if you have anything in engineering or science where you need to write formulas in, and it's a pain to get formulas into HTML, MathJax lets you put a LaTeX formula in just like you would type LaTeX into your browser, and it displays it like an equation. JSX graph is something that lets you build graphs of formulas fairly readily. This is nice. This is less so. This is what we are going to use for the next 5 years. This could easily get replaced next year by something that somebody comes up with that's better. But it seems to be the best thing we've got today. Some other tools. If you have a bunch of old Java applets, Google Web Toolkit will convert a Java applet to HTML5 for you. Their demo you can watch online. They've actually taken Doom, the video, the old computer game. They have it running purely in the browser in HTML5 now. PhoneGap is probably the best tool for taking an HTML5 page and turning it into a smartphone app. And also provides tools in case you want to use the smartphone features and things. So these are all things, you can find them, just Google them and download them. They're the tools you would want to do this. And let me talk a bit about, so what could you do with this? And this started as a challenge, and Chuck Moore, who challenged me, this says he didn't remember saying it, and he didn't mean it to be a big thing, but it really caught me. But he asked, how is an ebook different from a PDF file? We can get students ebooks. Is that different from just giving them a PDF file? Or is there anything interesting you can do with that? And with that challenge, for the last 2 years now, we have used an ebook as our sole textbook in differential equations. And this is the book. And you can sit there and say, oh, I'm interested in linear equations. This is MathJax. It takes a little while. You can see it saying processing math, taking it a moment now. And you could maybe see when it first came up, it came up in the code. And then it can write out a bunch of complicated equations. But all of this could be done with just a PDF file. What can't be done with a PDF file is students often complain they like examples. The book should always have more examples. This book always does. How many examples do you want? With a PDF file, it's a fixed file. This is now a computer package. It will generate examples by randomly choosing new functions and showing you, oh, so if you had this function, how would you do this problem? Suppose it changed to that function. It randomly generates new functions. The cycle is, I think, about 10,000 long. I didn't type in 10,000 examples. It just randomly says, well, it can even say, oh, do you need to remember how to integrate by parts? We can remind you how that went. And having checked online, the right place to send students if they've forgotten anything online is always Wikipedia. For every place that I have looked to say, oh, a student might need to be reminded about how to do this in calculus, where could I go online and look at the top 10 results on Google? And Wikipedia always has the clearest answer for you. But you can put that in there for them to say, okay, you want to see multiple examples. You need to look at old things. That's not something you can do with a PDF file, to have it generate additional examples for things. We also have some things, this is the page I didn't get, knew there was one I was forgetting to get up. EDU. Whoa. What do and it's going to ask me to sign in. So this is out of college algebra. This is this week's assignment, where we're looking at exponential growth and things. And you can say, what are you interested in with exponential growth? Different students have different interests. And if you want to see exponential decay of how much money does a Hollywood movie bring in, we can have that problem. But we can change the problems for you if you want. And let the students pick. They're basically the same problem. Here's some data, fit an exponential curve, and make a prediction from that. But the students can choose what is the area I'm interested in. Part of what makes math wonderful is it's available everywhere. No matter what you do, there's mathematics there. And we can let them pick and say, what are you interested in? Exponentials show up all over the place. Look at the data in an area of interest to you and answer a question about it. And try to let the text adapt to the student. Do you want more examples or fewer examples? The text can do that for you. Do you want to have the text talk about, technology things? Do you want to have it talk about agricultural things? Not to say that there's not technology in agriculture. Don't throw things, but how do you want to do that? If the text is online and the text is computer generated, the text can adapt to the student. So in the same way that Amazon has a different web page for each of us, because they've learned we like different sorts of books, can we adapt our teaching to the students? And there are a number of other things you can do with this. I mean, you can draw pretty pictures and type things in, type in new formulas. I'll skip that. When we did this, I didn't tell any of the students this was available online. I told them it was available online. I didn't tell any of them it was available on mobile devices. We hadn't tested anything on mobile devices. But differential equations is a class that is 80 to 90% engineers, and engineers play with things. And the first time I'm walking out of class and a student says, hey, I had a question about one of the examples in the book. And I said, oh, which one? And he handed me his phone. And I was just stunned. And I said, okay, which example is this exactly? But they have young eyes. They can actually read things on this. And I said, so you can read this online? He said, well, a lot of things don't work well, but your stuff seems to. And it's sort of, well, yeah, I've been trying to do that. I didn't want to tell anyone until I had a chance to test it. But the students went off and started doing that. Over 60% of the students, the very first semester, without being told it was accessible, were using mobile devices to access the material. And that's a year ago. It goes up as more and more students have smartphones and things. Mobile devices were defined for them as cell phone or iPad, not laptop. We found that, if you complain that the students have their phones out during instruction and they're doing Facebook, many of my students were probably doing Facebook, but not all of them. We have online problems that are randomly generated for the students and things. And they would be following along an example in class and say, now how does this work with the particular problem I've been asked to do? And they'd have up on their phone, okay, this is my assignment. Or I remember looking at this example in the book. Now he's going over it and I want to compare notes of things. And they would be following along on the book on their phone while they were going through the class. So I can't tell the students you can't take your phones out during class. Some of them are actually using it to do work. I suspect others are still doing Facebook, but that. In our help room, students will walk in and sit down with pen and paper, because I had a colleague who said once you get them working online, they'll never use pen and paper. And that's not true. They'll sit down with the phone seated in front of them so they can read the assignment, and then they'll do the assignment on pen and paper. But they move back and forth between them very smoothly. And they're doing this without my doing anything other than just making it available. Already they're starting to say, oh, I could do these things with this. I have my differential equations book with me at all times. course, the big question is, does this actually improve learning? And if you get one thing out of this talk, maybe the one thing I'd like to get is, that's the wrong question. Which seems odd to say improving student learning. But I would say the right question is not, does it improve student learning, but for whom? We have lots of different students out there. If you look at a redesign of a 1,200-person college algebra course, it is a mistake to say, what do I need to do to help the student? It is not the student. There are many different students out there, and they come in with different ideas, different ways of learning. And one of the things you will find if you look at the research on what people get by teaching with technology, people come up with a good idea. It seems like, yes, that ought to work. They implement it, and it has minor advantages. Nothing ever seems to make everything go better. And I think the problem is, why, yes, that was a good way of teaching. It helped some of the students. But if you help 10% of the students, the odds that you're going to get a statistically significant increase over the whole class is pretty small. But if you help 10% of the students, you're still helping 10% of the students. I think the right questions are the sort of questions Amazon did, of not saying, what is the best single home page? Amazon said, what's the best home page for each and every different person who comes here? Not to say, what's the best way to present this material to 200 students, but to say, what's the best way to hook each and every different student? Can we provide different materials? Some students need more examples, some students need fewer. Some students want to see things in one context, some students want to see things in another. That is what business is doing right now to try to sell things. And if we're going to sell math and English and literature and physics and humanities and agriculture and everything, we need to be thinking about those sorts of questions too. And can we recognize which students and get them the material in the form they need? Can we build ebooks that adapt to the students? And if you have the students doing their book online, you can watch them. You can see how they move through and get a sense of, how do students do things? Can we use educational data mining to understand not just how the technology works, but how our students learn and build new tools? JavaScript, HTML5 are the right tools for that. Thank you.